Last week, something unusual happened. While interstellar comet 3I Atlas disappeared behind the sun, NASA aimed a spacecraft at it that had no business being there. And what it found changes our understanding of where this visitor truly comes from. As you're hearing these words, NASA has just released the results of an extraordinary observing campaign: 12 spacecraft, 1 interstellar comet, and answers to questions we've been asking since July. On November 20th, Live Science published an article with a remarkable headline: 3I Atlas is a comet. NASA finally releases new images and addresses alien rumors. What initially sounds like old news actually marks a turning point, because this week, for the first time since its discovery in July, NASA released raw data from more than a dozen spacecraft that observed 3I Atlas from different angles. Among them, MAVEN at Mars, the Stereo satellite, the Psyche and Lucy probes heading to the asteroid belt, and yes, even the James Webb Space Telescope. But the real story begins on September 27th. MAVEN, the Mars Atmosphere and Volatile Evolution spacecraft, normally orbits Mars studying its atmosphere. Its imaging ultraviolet spectrograph is designed to analyze atmospheric gases. But from September 27th through October 7th, MAVEN did something unusual. It pointed its spectrograph at 3I Atlas. The comet was behind the sun at that time, invisible from Earth. MAVEN had the perfect viewing angle. What MAVEN saw was only published this week: a massive hydrogen cloud surrounding the comet's nucleus, its so-called coma. By separating different hydrogen sources from the comet itself, from Mars, and from interplanetary space, the team could isolate 3I Atlas's chemical signature. The result? The deuterium-to-hydrogen ratio gives us the first direct clue about the conditions under which this comet formed. Deuterium, heavy hydrogen, forms under extreme cold and pressure conditions. The ratio in 3I Atlas points to a birthplace in the outer region of a star system, similar to our Kuiper belt. But with one crucial difference: the star system it came from is likely older than our sun, possibly more than 3 billion years older. This week, NASA also made clear that the MAVEN observations were just part of an unprecedented coordinated campaign. 12 NASA spacecraft, from Mars orbiters to deep space probes, aimed their instruments at 3I Atlas. The Stereo satellite, actually designed for solar observation, used a technique called image stacking, overlaying multiple exposures to make the comet visible. It was actually too faint for Stereo's instruments. But through detailed image processing between September 11th and October 2nd, they managed to show the comet as a bright, fuzzy spot. Psyche and Lucy, both on their way to the asteroid belt and Jupiter, captured additional glimpses of the comet's tail. These different perspectives allow scientists to create a 3D picture of the coma and tail. And then there's James Webb. On August 6th, humanity's most powerful telescope pointed its near-infrared spectrograph at 3I Atlas. The spectroscopic data, only now available as a preprint, shows the comet's molecular composition: carbon compounds typical of comets, but with a signature slightly different from our native comets. But why this massive coordination? As NASA emphasized this week, 3I Atlas is only the third confirmed interstellar visitor. Oumuamua in 2017 was too fast, too small. Borisov in 2019 gave us more time but less technology. 3I Atlas is our best chance to study an object from another star system in detail before it disappears forever. Now, there are voices suggesting more exotic explanations for small trajectory deviations, but this week's data is clear. Outgassing from water ice completely explains every deviation. 3I Atlas behaves exactly as an interstellar comet should behave. When ice on the surface evaporates, it acts like a natural rocket engine, slightly altering the trajectory. This is completely normal for comets. The data shows nothing that requires extraordinary explanations. The story of 3I Atlas isn't over yet. On December 19th, in just under 4 weeks, the comet reaches its closest point to Earth, about 270 million kilometers. That's farther than the Sun, but close enough for medium to large aperture ground-based telescopes. The Virtual Telescope project in Italy has already announced it will stream a live observation. For amateur astronomers with a 25-centimeter telescope and dark skies, 3I Atlas will be visible as a diffuse smudge at magnitude 13, not spectacular but historic. In the last 2 weeks, the comet's ion tail has dramatically increased in length and structure. On November 11th, the Virtual Telescope project measured a tail of 0.7 degrees, about 1.4 full moon diameters. By November 19th, it had grown even longer. This indicates increased activity as the comet heads toward its closest Earth passage. 3I Atlas is more than just a comet. It's a messenger from our cosmic neighborhood, a piece of another star system that was thrown into darkness billions of years ago and now happens to glide through our space. This week's data shows we can not only detect interstellar objects, we can understand them. Every spectrum, every ultraviolet image, every orbital measurement brings us closer to answering a fundamental question: what kind of worlds exist out there, and how do they differ from our home? This is a special moment in history. The generation that watched the first humans walk on the moon now experiences the first detailed examination of a visitor from another star system. What Armstrong's footprint meant for our future in space, 3I Atlas means for our understanding of our place in it. We are part of something much larger. In 3 weeks, on December 19th, you have a unique opportunity. With a good telescope and clear skies, you can catch a glimpse of this visitor from another world yourself. It will be the last time any human will ever see 3I Atlas. Whatever it has taught us about the worlds out there, it will be the only memory we have of this cosmic wanderer as it returns to the darkness between the stars, never to be seen again.